The eDiagnostic remote for the eLoop range is a must-have for any installer of eLoops. The eDiagnostic allows you to calibrate and change multiple settings on your eLoop device, and it's simple to use. In this video I'm going to give you an overview of the eDiagnostic remote and what it can do for you. First off, it's made of high impact plastic with a silicone rubber cover. It's also IP65 rated, so it's tough and weatherproof, and it's powered by two simple AAA 1.5 volt batteries. Firstly, to connect the remote to your eLoop, you take the remote to the eLoop unit. Hold the diagnostic remote over the top of the eLoop or close to it and press the connect button on the remote. The eLoop will illuminate the set LED and the diagnostic remote will read that pairing has been successful. You can calibrate or uncalibrate the eLoop using the diagnostic remote by pressing Menu, then scrolling to Calibrate menu, then pressing the Set button to select Calibrate. The remote will display that the unit is calibrating and then loop calibrated. Now you can just scroll to exit and use the Set button to exit back to the main menu. You can use the remote to check on the loop's operation by scrolling to Diagnostic and then pressing the Set button. The diagnostic remote will now give you the live readings from the eLoop sensor. The reading is normal if it is between 0 and 200 points, as this is the noise threshold for the sensor. If we take a magnetic object and hold it over the eLoop, we will see the readings change in real time on the diagnostic remote. By default, the trip value is set to 800. That means that once the loop detects a magnetic presence strong enough to send the reading level over 800, the eLoop will send the open signal to your transceiver on the gates. The eLoop will flash the yellow LED to indicate an open command has been sent once the trip value has been surpassed. The ambient temperature of the eLoop unit is also displayed here at the bottom of the screen. The eLoop units can operate without issue in temperatures from minus 40 degrees Celsius to 80 degrees Celsius, or minus 40 Fahrenheit to 176 Fahrenheit. Scroll down to exit and press Set to exit this mode. In loop settings, you can change the mode of operations and trip level along with X, Y and Z settings if the eLoop is equipped with radar or presence mode. In the main menu, navigate to Loop Settings and press Set to enter. The first setting you can change here is the mode. If the eLoop is a presence mode unit, you can enable it here, or set it to exit only mode. And use the arrow keys to cycle through the options. Press Set again to select that mode. If you're happy with this setting, then you need to press the Set button again to confirm the setting, and then the Upload button to send these new updated settings to the eLoop unit. For any change of settings, you should make sure that you upload the change of settings to the eLoop unit. The next setting we can change is the trip value. Simply scroll to the trip value, press Set, and then use the up and down arrow keys to adjust the trip value. Press Set once you're happy with the trip value that you have chosen, and then the Upload button to send this setting to the eLoop. The XYZ axis is a setting that rarely needs to be changed, but in some more complex sites they may need to be changed. For example, in order to lessen the activation from a particular direction, such as the exit being in close proximity to an entry road. If this is the case, then you reduce the X-axis value. The X-axis field of direction controls the left and right hand detection areas, so reducing this in this case will solve the issue of a close passing entering vehicle in the next lane from triggering an opening when entering. The Z-axis controls vertical detection, and the Y-axis controls direction on approach and departing, in direction of the arrow on the eLoop. When you increase or decrease an axis percentage, you need to change a corresponding axis to compensate for the change. All axes should add up to 300%. So for example, if we want to reduce the X-axis to lessen the chance of a passing vehicle that is entering from triggering the eLoop, we then have to increase another axis to make up for that. So taking the X-axis down to 70%, we can then add 30% to the Z-axis, leaving the total of all three axes back on 300% total. Again, once you're happy with these and set them, you need to upload the new settings to the eLoop. For eLoops with the radar or presence mode, you can adjust various settings with the radar sensitivity. The first radar setting we can adjust is the release trip. This is what the magnetic field value needs to drop below to trigger the radar and let the eLoop know that there's no longer a vehicle present. It is set by default to 300, and this setting will only ever need to be changed in rare circumstances. We have the start lens setting here. This is the distance the radar will start detecting. 0.3 is the default setting, which is 0.3 meters or 30 centimeters, and again, this is a setting that will rarely need to be changed. The measure lens setting is the maximum distance that a radar will detect a vehicle. This can be useful depending on the types of vehicles being used and the location of the E-loop. For example, a trucking depot may want to extend the range for high trailer detection, or alternatively, an underground car park where high clearance vehicles are restricted anyway, may want to lessen the range and preserve more battery life. The radar trip is used to adjust the sensitivity of the radar. The higher the number, the less sensitive the E-loop's radar will be. The default should be 500 and this should not be changed unless advised otherwise. Radar confirm is a setting which can confirm a presence using radar once the main magnetometer sensor has detected a vehicle, and this is off by default. Radar INT or radar interval is used to adjust the time between radar reads when radar confirm is active, and this is defaulted to 15 seconds, but can be adjusted to anything between 5 seconds and 180 seconds. In radar read, we can check the radar functionality of the E-loop using the radar read here. The first 30 centimeters above the E-loop is considered a dead zone for the radar, so the object must be above this height to test the radar function. The radar's best reading distance is between 0.6 meters and 2 meters at a maximum distance. The last setting we can use in the eDiagnostic remote is the device info. This gives you the current software build date and then the software version. So that's a brief overview of the eDiagnostic remote for the E-loop range. Highly recommended for installers of E-loops as it saves even more time in installing and occasional troubleshooting when installing the loops. As ever, if you have any questions, please feel free to post them in the comments below and someone will get back to you as soon as possible.